Hello and welcome to the show, brought to you with the support of Media Proxy. Today we'd like to welcome Steve Doll from D2D Technologies. Hi Steve, welcome to the show.
Oh, thank you, Matt and Simon. Thank you for having me here today.
It's good to see you. So Steve, we're going to be talking about PBS WARN today. We're going to come on to that in just a minute. But before we get started, tell us a little bit about D2D and what you do.
Sure. So D2D Technologies, we've been around for almost 20 years. We have a background in multiplexing. And some of the areas in addition to multiplexing we do is EAS insertion, that's emergency alert system insertion, program guide insertion. Also do a lot of sending transport streams around the country using the public internet using the SRT protocol.
Okay, great. Yeah. So brings us neatly then onto the PBS WARN system. What is it?
Sure. So first, let me just give you a little background of what PBS is for some of your international viewers who may not be aware. It's a private nonprofit organization in partnership with almost 200 member stations around the country. And their mission is to provide high quality content which educates, inspires, and entertains. They have a lot of great programming, including educational children's programs, arts and theater, documentaries, and international programming. I actually remember when I was young that PBS was the first place I saw great British shows such as Monty Python and Doctor Who.
And there you go. Fantastic.
So they had contacted us a couple of years ago about a project they wanted to do called the PBS Warning System. And WARN stands for Warning, Alert, and Response Network. And basically what it is a backup to the emergency alert system, the wireless emergency alert system, those messages you get on your phone periodically. And the way that normally works here in the United States is the different government entities will send the messages over the public internet to the wireless providers such as Verizon, AT&T, and then they will basically send the messages out to whatever different phones are in that geographical area. But the question becomes, what happens if the internet's down? How do we get those messages out to your phones? Well, that's where PBS comes in. The alert messages will also go to the PBS satellite uplink, where they're sent over satellite to all the PBS stations around the country, where then each site, our D2 Warn system, will take the alert messages out of the satellite feed and inject it into the PBS over-the-air local broadcast. And those transmission will be picked up by the wireless carriers.
So what are the key requirements of the system?
Sure. First of all, the one thing that was very important from the beginning that PBS really emphasized was do no harm. That we don't want to do anything to the regular over-the-air broadcast. So the first step we did with that, we use opportunistic injection, where we basically replace the null packets in the stream with the alert messages, so we don't actually modify any of the data in the stream. It also had to be very robust. So we had kind of two modes, a fail-safe and a fail-over. Basically what fail-safe does is if there's some sort of catastrophic issue where the hardware just loses power or for some reason fails, it'll still pass the signal through uninterrupted. We also had a fail-over, which is where if the primary inserter failed, it would fail over to a backup. It also required SNMP for communicating between the two inserters and also for remote monitoring. This also needed to be a single unit solution. This is where the Ross openGear was a key component of the system. So we're able to put two of our insertion cards plus two satellite cards all within a single 2 UR frame supplied by the Ross openGear frame. It also had to have alarm and status indicators. And one of the other key functionalities it required was flexibility in functionality. As I mentioned before about PBS, and something I didn't realize until we were actually doing this project, is PBS doesn't actually own the stations. They're all actually member stations. So each one is unique. There's kind of a saying within PBS that if you've seen one PBS station, you've seen one PBS station. So we had to handle different stations using ASI, some IP, some 7310, some a combination of all three. So there's quite a bit different situations you had to be prepared for once the system was deployed.
So, I mean, that's interesting. So what was the process? What were the key steps in, because it sounds interesting getting, warning signals up to satellite and then down, via a TV signal and then out into the mobile network. What's the process? How do you start to develop that kind of tool?
Sure. So once we were awarded the the contract, we spent about 3 months ironing out the statement of work. And it's not only a technical process, but also had to get upper management approval, legal teams involved. And one of the things we did during that process, which became very important, was we built in some pre-approved funding for unanticipated features, modified functionality. Because just sometimes, you have this great plan, but once you start implementing, realize it doesn't quite work the way you're expecting to. So it's good to have this sort of built in so that when these situations came along, you didn't have to go through that whole process again of getting all the upper management involved, legal teams involved. We only had to get approval from the PBS WARN team that we were working with. And once we had that statement of work, the next key step was to break that up into tasks and milestones, which could be easily managed. We actually use the JIRA management system for our project management. And it's very important also to have an iterative process. We had weekly meetings and code updates with the PBS WARN team. We worked very closely. So that way they could see week by week how the project was coming along. They could test it in their own. They had a demo unit at their site. They can be tested as we went along. So that way we can really keep track of that we're on schedule. It's working how they're supposed to. And this is where kind of what I was saying, having that pre-built-in funding is, as we're going along, we ran into this issue called rain fade. If you're not familiar with that, that's with satellite reception, rainy conditions, the signal can go in and out. And when we first started testing, that was causing it to fail over to the backup quite often. So we had to kind of go in and tweak things a bit so that we had a better understanding of when it was just rain fade and not an actual failover, so we wouldn't fail the system over. And once you have a system ready to go, it works great in our lab, works great in the PBS lab, but you really need to get it out in the real world. So we had about 10 stations lined up for beta testing. It was really nice because we had a mix of some were ASI, some were IP, some were hybrid, so we can actually see the system working in different environments before we actually fully deployed it. Then after it's deployed, things aren't over yet, because really probably the key thing is support. Making sure we're always there if there's any issues. We support it. We add enhancements. We actually it's nice once we got the system out and started getting feedback from the individual stations. They'd be like, "Oh, it's working great, but it'd be really nice that it did this." We took all that feedback, and about 6 months after it was deployed, we did another update to kind of take in all that user feedback.
So, Steve, how important was the openGear element in the project?
Critical. It's kind of understanding that was kind of one of the key features in us being awarded the contract was to have the whole solution within a single product. So even though it was redundant, there was 2 of everything, it was still all in one single 2RU frame. And that was definitely the feedback we had from PBS was a major decision point in us getting the contract.
D2D Technologies has been around for quite a while. I can't believe this is the first custom project you've done. Tell us about some other work you've been involved in.
Sure. There's a couple others which come to mind. There's Three Angels Broadcasting, which is a religious broadcaster here in the States, and they're doing a satellite distribution that we had our equipment at each site receiving the over-the-air or the satellite feed. But one thing they needed to do for government compliance was be able to insert alert messages. And they didn't want to go through the expense and the quality degradation by decoding and re-encoding at each site to put the alert message in. So we came up with a method to basically take the alert message, replace all the programs in the stream with the alert message for the duration, then when it's done, switch everything back. So that way they can be compliant without having to decode and re-encode at each location. Another custom project we did was in Mexico, with a system we ended up calling D2 Propel, where they were also doing a satellite distribution. And in this case, at each site, they did need to do a decode and re-encode because they're inserting local content at each location. But the one issue they had, though, is they needed program guide information. And it was the same program guide information every location, but since they're doing a decode, re-encode, if they did the program guide generation at the uplink, it would all be lost. And so they're looking at the expense of having to put in a generation at each location, which would be very expensive and very redundant because it'd all be generating the same guide information. So what we did with our system, which is already deployed at each site, was we took the satellite feed in with the guide information. We'd take the guide information out, send it out our first output to be decoded, re-encoded for local content. Then we take it back in our second input, put the guide information back in, and send it out our second output to go into the transmitter for broadcast. So that way they can only have one guide generation at the uplink and not have to have that added expense of having one at every location.
Yeah, I mean, part of me wants to also see whether you've learned anything over the years of doing all of these custom projects. You must have identified some vital, some key elements that both you and the customer need to achieve.
Sure.
When you're entering into a custom project like this.
Correct. Yeah. Here at D2D, we love doing custom projects. It's very challenging. We really like that working one-on-one with the customer, and also being a small, nimble company. It's nice that basically with the PBS project, I was pretty much involved in every phone call and meeting. So if something needs to be changed, it doesn't have to go up through 4 levels of management to somebody who's not even involved in the project to make a decision. I can make the decision right there. So we can be very flexible. But some of the other keys we learned was that, it's important to have a very detailed and comprehensive statement of work, that you should build in flexibility, because there's always going to be things that you didn't think of, or you thought would work one way, but once you actually implement it, it doesn't quite work the way you thought. So you want some flexibility built in. You also want to be able to break that statement of work down to smaller tasks, which can be easily managed and tracked. You want a very iterative process. We work closely with the customer so ensure the project stays on the schedule and it's meeting what they're actually looking for. It's also good that before you actually do full deployment, you want to do some beta testing in some real world environments. And finally, just the ongoing support and enhancements based on customer feedback.
Yeah, there's some good advice there. Steve, thank you very much indeed for your time today, Steve. It's been great talking to you.
You're welcome.
Learning about your solutions and also the openGear solutions as well. And on the point of openGear, you can check out our channel for the other openGear partners that we've been chatting to over the last couple of months. Do also go to d2dtechnologies.com, where you can find everything that Steve's been talking about, and also there's a full-length case study on there as well. Thanks to Media Proxy for their support of KitPlus TV, and thank you for watching. We'll see you next time.
All right, thank you for your time.